So this is in the notes still. Okay, so trig proofs, notes. Everyone found that spot? Notes. Notes.
Does it look like this?
That's the workbooklet, yeah, but we're back to just the notes right now. Okay, so this table is some guidance on steps to look for. Okay, so step 1. When you're trying to prove two equations, you can use substitution. So here's some examples. If I ever had a tan x, what could you substitute in to replace tangent?
I don't think that's the same.
Okay, so substitution. So my examples were, what could you substitute in to replace tan x? Somebody know some equivalent trig ratio? Sine x over cos x. I could substitute something in for secant x. So what's the another trig ratio that is the same as doing secant x? 1 over cos x. So these are substitutions. Another example could be, what could I replace cos squared x with? So that's a formula sheet. Something on your formula sheet you could replace cos squared with. So I'd look here, I could replace cos squared with 1 minus sine squared x. Okay, here's another strategy you could do. You're going to get a lot of fraction stuff. Okay, so when you add and subtract fractions, you're going to have to make common denominators. So here's an example of something you could run into. 1 over sine x plus sine x. So really, this has a bottom of sine x and this has a bottom of 1. You can't put them together. So what would you do? You would change this bottom to become a sine x. But what would you have to do to the top then? You would also have to multiply it by sine x, which would turn it into a sine squared x. Okay, so that's an example. I don't think I meant to write that in wrong, but now that I see it there, it was wrong. Okay, another thing you can do is cancel. So we know from fractions, anything from a top and a bottom as a multiplier can cancel. So if you had sine x over sine squared x, do you see you could divide? I could cancel a sine out, turning it into a 1. And if I cancel a sine out of a sine squared, you get just that, right? So this is what I would get. And then I'd be like, oh, wait, 1 over sine x, that's cosecant x. So you can play around with things like that. Okay, here's another example of a strategy, splitting up a fraction. So here I have 1 plus sine x all over sine x. Well, I could split them apart like that. And then I could get 1 over sine x plus sine x over sine x. Okay, then look, this is cosecant x. And this is 1. Okay? Okay, then we have factoring as a method. So let's quickly talk about factoring. You could see a difference of squares, recognize that. That's the one you probably run into the most. And here's why I would run into it a lot, is because of these ones right here. You see that's a difference of squares right there? That's why you're going to probably run into that one the most. GCF, you run into that one quite a bit as well. You probably won't see as many simple and complex trinomials. Okay, so here is an example. You ready? So what I did, you can see here I did a difference of squares. Do you see this? Difference of squares, split apart. Then on the bottom there was two terms. So what did I do? I GCF'd a sine x out of them. Then this factor and this factor can cancel, and that's how I got to the next step. And then I split the fraction. That's how I got to the next step. And then I substituted. So 1 over sine is the same as cosecant, and this is the same as cotangent. Do you see how this involves all these math strategies? Okay, so you're going to have to think about all these. And the last one is multiplying by a conjugate. So you learned that word in grade 11. So a conjugate is when you have a binomial and then you times it by the same thing with the opposite sign though. Okay, so once I do that, it should create a difference of squares. Okay, that kind of thing. Okay, so what we're going to do is we're going to start easy and work our way to harder. So this is a super easy one. Okay, so here we go. What of these strategies do you want to attempt? I'm going to pick substitution. That's my strategy. I'm going to do some substituting. What is there anything, do you see anything you could make a replacement for on this? I can replace tan theta. So what is the same trig of tan theta? Sine theta over cos theta. So there's my replacement. Times cos theta. Okay, I'm just going to work on this side of my chart. Then would you agree that this and this would cancel? And after they cancel, I get sine theta. Does this side look like that side now?
Yeah.
That means you're done. Once you've shown it, you have to just prove it. So once you've shown that they are the same as each other, you're done. So you can write left-hand side equals right-hand side. Or you can write QED, which is Latin for, I should remember this, there, that's what it means. Quadrat demonstrative basically means, look at it, I demonstrated it. So that's kind of fun. QED. I did it. That's what it means. I did it. Okay, so when you're doing a proof, here's another thing we're looking at, is that we don't ever write an equal sign, ever, until the end, till we show it. So just work separately. Okay, we are going to work again with some substitutions. So can you make a substitution for secant theta? What can I replace secant theta with? It's the flip of cosine. Divided by what can I replace cosecant with?
Flip side.
Flip of sine. So you can see what I'm doing, I'm replacing. Okay, now this next step would just be a math step, fraction divided by fraction. So times and flip. And then this would create a sine theta over cos theta, which can be replaced with tan theta. So you could write that underneath, or you can work on this side and make this statement. You can work on both sides until you've matched somewhere. So you could have gone under here and wrote just tan theta, or you can work down from that side. As long as you're making the appropriate substitutions. Okay, next one. We're gonna do substitutions again. This is another, I'm gonna add another strategy in here. Whenever you start proofs, you should work on the side that looks trickier, more complex. So whatever side looks more complicated. So for me, I am going to start on this side because it looks more complicated. When I see things that are coses and sines, I feel like that's as low as you can ever get to in trig. There's nothing that you can get to past just a sine and a cosine. So substitute, please. Give me something here and something here. And you know what I'm going to do? I'm going to think about the end goal. The end goal is that I only have coses and sines in it. So when you make replacements, can you think of what could I replace that would just have coses and sines? So cotangent should be replaced with cos x over sine x. Does that make sense? And tan x can be replaced with sine x over cos x. Okay, we are working with an add fraction. So what's the big idea with adding fractions? Common denominator. Okay, so what do you all want to put in a common denominator? What do you all need to include? You would need a sine x in there, and you would need a cos x in there. Would we agree? We need both of them? Okay, so if I look at this fraction and then what we turned it into, what would we have to multiply by? From here to here, what happened to the bottom? We got times by a cos, so I would need to times the top by a cos as well. So what does that make? Cos squared x. The bottom of this one is cos x, and now look at the bottom. What happened to it? It got times by a sine x, so that means I would have to complete that on the top, making sine squared x.
Why is it sine squared x, not sine x squared?
Okay, so here would be the difference. It'd be like doing this. This in math would be, can you find the sine of 30? Boom, 1/2, and then square it. Okay? So like 1/2 and then square that trig value. And if you put this squared on the angle, so this was like that format, and this would be if you did it like this, which is incorrect, it'd be like me doing what's the sine of 900 degrees.
Yeah.
Not what we want. We're trying to square the trig value. So that's a really good question. So this is actually the same idea as that. Those are the same ideas. You're taking the trig value and squaring it. This is the wrong idea because this is squaring the angle, not the trig value. Does that kind of make a difference in math? That make sense? Okay. Does anybody see anything, and it's formula sheet related? You see it, Locke?
Sine squared plus cos squared equals 1.
Sine squared plus cos squared equals 1, which means I can replace that with 1 because my formula sheet told me I could. And Locke, did you know that, or did you kind of peek at the end result to say, like, where am I going, and giving me a hint? Okay, so again, sometimes look on the other side for hints, like where are we going? And then we're done. We did it. We showed it. Okay, we got a couple more. Okay, a little bit more complicated now. Ready? Which side would you pick? This left side or this right side? Which one looks more complicated? I'm gonna pick that side. Okay, let's look at the end. 1 plus cosecant. This has nothing to ever do with cosine over here. Does that make sense? There's no cosines in here at all. This is the flip of sine. Okay, so there's no cosines. So here's my first thinking. Is there a replacement for that? Because in my end, I don't ever want to see a cosine involved in the end. So is there something from a formula sheet that you can replace there? 1 subtract sine squared x. Okay, for a candy, no big deal. Out of this chart that I gave you a chart with some strategies. What strategy would we do?
Simple.
Cancel.
Who said factor?
He was naming every factor method.
That's somebody else?
I named
Oh, make it there.
He named every factor method though.
Factor. Okay. I heard cancel, which is a big common misunderstanding, which is wrong. Okay. No, it's very wrong. It's highly illegal to cancel.
Yeah, come on now, bro. Come on.
Okay.
This guy got-
We talked about this last year. Ready? 4 plus 5 and 3 plus 5. If you have that, can you, oh, this is 4/3. Does that make sense? No. That's an illegal cancel. 4 times 5 over 3 times 5. Can I cancel here? Yes. This makes sense. So what was the rule last year? You can cancel multipliers. You cannot cancel adders. That's the number one common mistake on proofs.
I hate whoever made these rules. Oh, maybe not.
Okay,
It's a bad word.
so you cannot cancel those. Do we see it? You can't cancel them because they're adders. So the strategy we were picking is factoring. What style is the top? Difference of squares. 2 brackets, difference of squares. 1, 1, plus, minus, and then sine x. Oh, I already heard it, GCF, the bottom. So this bottom is a GCF, so 2 terms. What's the common thing to take out of both? Sine x, bracket. Sine x times what? Sine x times what? Sine x times 1. Okay, now you can do what you really wanted to at the start, which was to cancel. It can happen now. Because it's this times this times this. So this factor is now a multiplier. I'm just rewriting this, you don't have to, but. Okay, 2 things we can do. You pick what we want to do. At this stage of the game, I could split this, or we could jump to the other side and work on that side. What do you want to do? Other side? Okay. So on the other side, 1 plus, replace, substitute there. 1 over sine x. So how do I add? That would mean I need to make the bottom the same. So they both need to contain a sine x. So if I was to make that a sine x, right, I'd have to times the top by sine x. And there we go.
Wow.
We did it. So in a proof, you know if you're right or wrong because you get there, right? So do you see if I were to split the fraction? So if I had split the fraction, this would have been my cosecant, and then this would have been my 1. So that could have worked as well if I just gone on that. Okay, last one of the day. Which side do you want to pick? Sometimes it happens where you just try something and you don't get anywhere and you erase and you try again. But trial and error. Which side do you want to start with? The left? Oops, why did I put tax? Tan. Okay, so must have been a tax season there with that question. Tan. I'm going to replace it with sine x over cos x. Secant. I'm going to replace it with 1 over cos x. And they both have a cos x on the bottom, so I don't have to do anything except for go sine x plus 1 over cos x. And they don't match. Okay, so now what? Okay, for candy, look on your charts. You can find one of those strategies.
Common denominator, 1 plus 1.
Nope.
Split the fraction.
What did you say?
Is it conjugate multiplication?
It is conjugate multiplication.
That's a good guess.
Conjugate multiplication. Okay. So I'm gonna pick either this binomial or this binomial. It doesn't matter. What do you guys want to do? Okay, let's go this side. So cos x over 1 minus sine x. Okay, conjugate multiplication. This is how it works. What's the conjugate of this binomial? 1 plus sine x, which means I'm going to do the same thing to the top. Okay, now here's some forward thinking. Do you see this 1 plus sine x? That's kind of what I want to leave. Look at, that's the end. So that'd be nice if that could just stay there. So I'm going to actually leave the top. And the reason was because I saw the end goal and that gave me a hint. Okay, we need to work on the bottom though. Foil that out. So conjugates would always foil to look like a difference of squares, by the way, right? 1 subtract sine squared x. Does that make sense? When I foil, because your outs and ins cancel, right? Okay. Here, substitution formula sheet. I recognize it from the top corner. 1 subtract sine squared. What is it replaceable with on your formula sheet? Cos squared. So I'm rewriting the top, and then I'm going to replace with my formula sheet. Now what would you see? A cancellation, so cos x can get reduced out of both. And look at that, what did we do? We look like we match now. We now match the other side. Okay, I think that's it.